Excellent. Thank you very much. And first of all, thank you very much for having me, as I have really looking forward to do this presentation. One of the good things about being the second one who tells something about industrial security is that some of the things have already been mentioned in the first thing. So just a quick show of hands, anyone who works in a company with industrial network or production? And then the next question would normally be who have done anything security related, and then the bonus question is if you actually have tested and you got stuff, going really wrong. I have done that, and that's some of the experience I really would love to share with you. And there's two things I actually would like to apologize for. The first one is that during my presentation, I might be a bit harsh on IT security do's and dudettes, and I would also like to apologize for some of the colors. For whatever reason, this, the blaster cannot like red, and that's a problem when your logo is orange. So apologies up front for that. Exactly. So this is me, blah, blah, blah. I have 25 years of experience. For the last 10 years, I've been working only within industrial security. I've been working in transmission, energy, and done a lot of other, fun stuff. I'm a part of the representative in Denmark for NATO, and have done a lot of other different stuff. And then, last but not least, sometimes I will refer to something called ICS range. And ICS range is one of our, services. And basically, you can see it's an OT-centric capture the flag platform with real security. And I'll just briefly tell into that a bit later. Oh, sorry? No, it's the stuff we use is open source, but basically when you log in, then you would be access to real industrial equipment. So it is a service, but it's not purely open source. However, we use a lot of open source, and our contributions back to the community is very often whenever we get real industrial things, we pen test them. And then I always say, because my research assistant already called me and said, "Hey, Mikael, we found a bunch of vulnerabilities here." So I know there's always a lot of talk with the vendors afterwards. So that's our kind of contribution. So per se, not open source, but I hope that answer your question. Cool. So what we do, we are breaking stuff, as I just shortly mentioned. We have this platform. One of our main goals would basically be to do that everyone would be able to learn security testing and pen testing, because just as on the panel here, we have a huge gap in the talent pool for IT security, and it's even bigger within OT security. And basically also we do a lot of assessment, and this is like the knowledge and what the takeaway from those assessments I would like to share with you today. So first thing first, I always have this in my presentation. Everyone who comes with an IT security background, like I did, I had 15 years of experience when I started to look into OT security, and I thought, I know everything about this. To paraphrase Yoda from Star Wars, whatever you have learned in IT security, you must unlearn what you have learned, because it might look the same, it might feel the same, but there's very often a huge difference, especially when you're doing security testing, when you're doing pen testing. So this is something I'm not going to go too much deep into. When we are talking about IT, we are talking about stuff that interact with data. When we are talking about OT security, which is like the overlapping arch of the description, we are something that interacts with the physical world. It might be the local power grid, it might be building a facility like this, what keeps the air condition running. And basically you see the biggest difference is that in enterprise security, you're looking into protect the data. Whenever you're doing a pen test, how can I get access to the thing? But when you're looking into ICS security or OT security, you're looking to secure the process by itself. Because nobody have ever been promoted for updating a system or pen testing a system, then suddenly half of Albania is just having a blackout. So again, we need to do things a bit different. The brief story of security is that if you look into the security poster, you would probably, for everyone who have been working here for more than 5 or 10 years, you would feel like this would be a blast back to the present. There's a lot of the security models that is very old, because original it was thought that this system should be separated. And just imagine that having a system where you design it to be separated, one day suddenly find itself directly faced on the internet, then we might have a slightly problem here. Of course, the data must flow, but that doesn't necessarily mean that we should be able to be finding them on Shodan. And last but not least, a lot of the protocols are rather old, so there's no encryption, and there have been that if it's not broken, don't fix it. However, for the last 5 years, this has been changed really much, particularly because the vendor has found out that eventually security is something they need to take seriously. Yes. If we look into traditional IT security, everyone who have been on a one-day security crash course who have learned something about, we're looking into confidentiality, we're looking into integrity, and we're looking into availability. That's all good. But however, when we're going over to the OT side of the house, the scale change. Then we're just suddenly looking into safety. And safety is not the same thing as security. As one of my co-workers once said, that one of his prime concern was that his employees was able to come home to the family safe and sound. And as you can see, then you just have confidentiality in the lower part. So again, it's another ball game, but it's something that we still can use to our advantage. So, just a little quick quiz. If we're looking into what have done the most outages in power grids, the number has been taken from the US power grids, but I'm saying they're probably pretty comparable all over the world. So besides, force of nature, what would be the top 3 root causes for power grids? What kind of creature would you think that was the number 1 reason for power outages? Any guesses?
Physical faults of equipment.
Sorry, once again, please.
Physical faults in equipment.
Yeah, you are almost there. If we're looking into nature, we normally say, thank you. We normally say that at one point, when the hackers and the adversaries learn to train squirrels, we really do have a problem, because that's the most predominant way of outages. All right. If we then look at humans, what kind of creature would you think that would be the second most responsible for all outages? Any guesses? Perhaps you have a good idea? No, that's fair enough. I'm not going to put you on the spotlight. Ladies and gentlemen, the second most responsible thing for outages is the IT security moron. The person who thinks, I know IT security, now I'm walking into another facility and I take all my knowledge and particularly all my tools and use them again. This is a really, 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 really bad idea. I can give you a very good example. There was a large incident in the US back in 2019. And basically they said, we know our IT network has been compromised. Perfect. We are not sure if our industrial network has been compromised. So they called in a bunch of high-paid consultancy doing incident response and gave them that task. And one thing that is very predominant within industrial security is that the network drawings might not be accurate and they might not be, from this century. So the guy said, it's not a problem that your documentation is not up to par. I have a tool, something called Metasploit, which can help us a lot. Let's just put it that way. Out of all the tools this person could have chosen, it was absolutely the worst, because that when he did run that, if they hadn't had an incident before in the production, they particularly had it afterwards. Ladies and gentlemen, the point of this presentation is that you're not going to be that person who's doing that kind of problems. And then last but not least, we see the all the time in the news, it's advanced persistent threat, state-sponsored XYZ fluffy bunny or whatever. So isn't it actually quite interesting that our own IT security people are responsible for more outages than everyone else? So we have, sometimes we also call the OT like Industry 4, and what I think is quite interesting, if we're looking into industry number 3, is back from the 70s, we haven't figured out that security model yet. So now we just go into 4, and it's going to be really, really awesome. It's going to, anyone who's going to be interested in this field, I can guarantee you would have a job until you choose to retire. So the strength and the weakness is that it's built to last. It's very simple to IT environments. But I would like to quote one of my very good friends. He's a godfather of my daughter. He said, if Mikael can find vulnerabilities in those kind of systems, believe me, anyone can. You know, with friends like that, you don't need any enemies, right? So if we look into the lifecycle prediction, and why is this so hard actually to do pen testing on? If we look into your average mobile phone, laptop, probably about 3 years, then you're going to replace it. If you're looking into different product environments, it's going to be 8 to 10 years. And then when we are looking at energy and other kind of environments, it's something like 20 to 35 years. And then just a little thought. Imagine that you are sitting and doing architecture reviews, and you're doing, just imagine that when you're doing a design for industrial security, you need to foresee what kind of problems are we going to have in 20 years. Good luck with that, ladies and gentlemen. And that's why even today we see, okay, there's a lot of interesting findings and things. This is the reason why, because nobody can predict the future, at least not so far. So, with that short, very short introduction, now I'm going to talk on the main topic, like pen testing OT, and then knowledges from the real world. So, how to break stuff. Never ever please doing industrial testing in production, unless you really need yourself a new job and you're too lazy to write a resignation letter to your boss. Because this is a really excellent way to get yourself fired, ladies and gentlemen. Don't do that. One of the things is like Nmap-O-A. As some of you might know, Nmap is, like the default support scanner. When you're doing a -O, you're saying what kind of operation system is it running, and the A is like what kind of applications thing. And the way that Nmap find out what kind it sends a lot of different packages, a lot of invalid packages, and based on the response, it would actually see, okay, based on this profile, it's like a Windows 2016 server or whatever. The biggest problem is that a lot of those IT equipment is perfectly fine, but when you move into the OT environment, then the implementation of network is very, very strange sometimes, and giving a lot of invalid requests would actually break stuff. I didn't believe it myself until I started and doing some testing when I started back in 10 years ago, and then suddenly I had equipment who just went boom on me, and that's. At that time, I was really happy that it was in lab testing, so it wasn't in running in production, because otherwise things could have gone really bad. Again, don't bring a USB drive with all your fancy hacker tools and malware. And then, last but not least, the testing is possible, but we need to do it in a good way, and we need to come prepared. So, if you have any slides you would like to, I would ask you to remember, it's like, please read this one. Because before you start to doing penetration testing, start to have an okay from the senior engineers. Those people, even that they might not be technical, he or she would be able to say, okay, this equipment would most likely be able to withstand, this one would definitely not. And then, preferably, if possible, test the devices, in individual non-production networks. It's not always possible, and that's, one of the exciting things about it, but, if it's possible, start to do it in a test lab before you break stuff. And then last but not least, particularly when you're doing on-site testing, triple test the client for the IP addresses you have been given. I know this sounds really modern, it's really like simple, but very often we have been out on the test, we have got a list of IP addresses, and we start to look into it, and then we see, okay, this .10, it doesn't seem to be whatever scope target we have been given. And then the engineer goes all wide and said, oh my God, it should be 110 instead. So again, stupid human mistakes, but again, always, don't always trust, but also validate. When you're doing live testing, ensure that you actually have senior people around in order both to test the systems and to recover the equipment, because stuff might fall over even with the best of your preparation. I can give you a good example. We have built an internal 12-step guide for whenever we're doing pen testing, and basically means like we start with the least likely things that can go wrong, and then allocated a lot of time between them. So that means, an example, we're sending, just some simple things as ping packages, and then we said, okay, now we're waiting 15 minutes. Did something break? No, it didn't. Cool, then move on to the next step. And this 12-step guide, basically, it takes a day to do it, but we have good, good experience with that. Another thing you always should ask the client on, because again, that's a big difference between IT and OT. You said, okay, why would you like us to do pen testing? Very often the client would go back and say, I need to know what kind of vulnerabilities there is. And then I'll let you into a little trick. Just by doing passive pen testing, meaning that you would capture the network traffic from the environment. You can do that via span or mirroring port. That was considered to be quite safe. Then you would have that information, and then you can work on that rather than to doing active intrusions on the test. Very often, the pen test would be able to stop just there, because you would, in normal circumstances, you would get a lot of vulnerabilities just by looking at, okay, this is like a Siemens S7 1200 PLC, it's running firmware XYZ, and then you would be able to see a lot of vulnerabilities. So compared to IT pen testing, this is a very easy way to do your job. And again, very often then the pen test would actually be able to stop there. Sometimes I'm so fortunate that particular vendors comes out and said, well, we're not interested about the CVS scores that are already known. We would love you actually to do testing, like zero-day hunting, and then we would go in and do that. So, yeah. All right. Just to give you a little example on how easy it is to do threat hunting and IOCs in such network, we have something called Modbus. It's very close to being a protocol that is 50 years old now. It's a client-server model, so it's predictable how it's supposed to communicate. It doesn't have any kind of encryption, and it doesn't have any kind of context. And with that, I mean that if you have the right command, you would be able to interact with Modbus. Because it said, well, if you know how to communicate with me, you're probably a good guy or girl. Welcome to the security of OT, right? It's interesting. It always, and another simple trick is that whenever you're doing pen testing, if you're looking into Nmap or some of the other node tools, it would always look in for the protocol called 43, which is basically read device identification. And a good thing is that if you're ever going to do blue team in industrial thing, this is one of the first things you should look after if you're running Modbus. And believe me, almost all networks are running this kind of service. Because no engineer, he or she with her salt word, would ever run this module. But it's the first thing that a hacker would do. So you have something, clear text, no valid reason to use it, but this would be the first thing an attacker would do. So look after this, please. And this is when things get really scary. Again, back to the ICS range we have. Sometimes vendors approach us and said, hey, would you like to resell our stuff? And I said, no, it's not what we do. And then they said, hey, can I donate you some stuff? Yeah, of course you can do that. This is something coming from China, and you can buy it on Alibaba. Basically, the price is $120, which is roughly about 10 times the 10 times reduced price of what Siemens, ABB, and everyone else does. And basically, it can communicate to everywhere. So just imagine then suddenly you have stuff where you thought it was being protected, and then you just have a direct internet connection straight out. When you're doing pen testing, look for those kind of devices, because very often it has been attached to the network, but the asset owner might not know it, because this is There was a big incident in Saudi Arabia some years ago, and part of this thing was there was a vendor who put up some equipment that definitely should not put up. And so, yeah. As one of the previous speakers said, it's quite interesting. Out of this 10, 12 kind of malwares we know, the last 3 came after Russia invaded Ukraine. So of course it shows out that there's a huge interest in those kind of areas, and also make really, really good sense, because that if you can, attack a city's infrastructure, it's much easier rather than sending soldiers. Because just say, hey, someone could just take better care of their power grids, an example. And other little resources when you're doing pen testing, go for the easy apples, right? The low-hanging. Look at this list. It's available on GitHub, and someone have taken the time to go in through a lot of dusty manuals and looking into what's the user credentials and passwords for a lot of different systems. If you find this, well, you can just log on. And the good thing is most of those equipment are single user, so you only have to log in with admin, and then, as you probably can guess, the password would very often be admin as well. So again, save yourself some time, show you some of this. As the previous speaker talked about, there was this attack back in Ukraine 2015, the Black Energy attack. And let's see, I can see we're a bit short on time, so I'm not going to. But the really interesting part was that in this attack, one of the most, 90% of this was IT attack, and 10% was, industrial attack. And they attacked something called a little Moxa, which is this little thing here. It's been used everywhere globally. And I've never had such thing, so I went out and bought it for 50 euros. And within an evening, I started to find vulnerabilities there. You can see this 1 year later. Oh, sorry. 1 year later, then me and 2 other researchers was being credited for, post-mortem finding the vulnerabilities there. So again, back to my good friend saying that if I can find vulnerabilities, it's just way, way, way too easy. Last but not least, if you run Nmap, and again do it in a sensible way, there's a lot of old scripts. And again, if we go from the IT world, you will say, oh, but those scripts, they are 5 or 8 years old. Believe me, they still work, because this is a word in OT, it doesn't change a lot, it doesn't work very fast. So again, another resources, if you look into that, you have we had the ICS protocol that was mentioned this morning. There's a script for that. We have something for Modbus, the one with section 43. S7 is for Siemens, one of the most deployed PLCs around the world. So plenty of stuff to go out and start to have fun. And if you really want to have systems start crying, there's a little attack called Black Nurse, which is basically a ping attack, ICMP package. And basically says this attack just say, hey, I don't know where I'm going, and I don't know what's wrong. Believe me, even today, most industrial equipment, they would just die on this kind, or be really, really, really sad on it. So just imagine this simple attack would burst if you have been granted OT penetration testing. If you can't find anything else, this is your Hail Mary. You would find something just by this. So please remember, every machine is a smoking machine if you operate it wrong. This is particularly correct in OT. And but again, remember, you can actually do pen testing in industrial networks. You just need to use the IT security attitude, forget about talking patching 24/7, zero trust, and all the other things. Very often you can turn the weakness of OT security into your own personal magical powers. An example, unencrypted traffic is a really good thing on those kind of networks, because it tells you what kind of devices, what kind of firmware do I run. So it's really, really easy to do pen testing in that. Limit the exposure to networks, and then start looking at funding. If anyone are interested and have skills in that, we're always looking for skilled people and freelancers. And with that, I would say thank you very much, particularly to you. Thank you very much for the